additive manufacture and top quality cutting tools that can be reground with Quickgrind. If you want to start participating in the circular economy, you should be checking out Quickgrind for your cutting tools and maybe looking at additive manufacture. Additive manufacture is a fairly new technology that seems to be creeping into production parts every now and then, and people are trying to develop new concepts as to why you would use it. Now Ryan, what is this ring? Can you explain a little bit? What material is it? What are you making?
Yeah, so here we're depositing a ring using laser metal deposition, additively manufacturing it out of Inconel 625. And we are doing this as a sort of proof of concept for oil and gas sort of components and customers to show that additive is a viable way to start making these sort of high performance parts that they may use down well.
Okay, let's take a quick look at it.
Yeah, let's have a look. Yeah, so this is the ring here, and for making this we used the laser metal deposition process to build.
So none of this is started off as a billet?
No, so we're starting off from a blank substrate here. We're using laser metal deposition to sort of build up a few layers at a time, and then using a machining pass to come in, flatten off the top of it.
Why
here.
did you need to flatten off the top?
So for us there, this was proof of concept of being able to do a build in stages. Now, for that could be for managing a sort of geometrical sort of problem, or it could be purely a time perspective. You could have a part which could be running for days, weeks, months as required. So this was a sort of way we could prove that this part could be done in stages as required, in almost a bit of a modular way. You can keep going to the point you require height-wise.
Okay, and what problems were you having while trying to machine the skin off, off this part in stages?
Yeah, so as deposited finish is quite rough, there's sort of peaks and troughs with it, and that obviously creates some quite unstable cutting areas. We were having some issues with tools really wearing out due to being Inconel 625 and due to this hard skin.
And the surface of this hard skin looked absolutely awful. It's like you say, peaks and troughs. It's a really dark, horrible colour, whereas this is a beautiful finish you've got on it at the end. Is the skin also a little bit harder?
The skin is actually probably a little bit varying, so you can have kind of harder bits and softer bits at this extremity. Once you're into the part, it is quite homogeneous, but that skin is really the difficult bit for us to get
Okay, so
through.
what problems were you having trying to machine that skin?
So trying to machine that, it was quite common for the tools that we were using to be wearing out very quickly on it, perhaps only getting one sort of facing pass out of a tool before it kind of worn it out beyond.
So how many tools did it take to machine this?
So if we were doing that up in perhaps maybe 15 layers, that would be 15 tools.
15 tools?
So purely just if you're using one per layer, that's how it ended up.
So it's like you're getting through a lot of carbide when you're trying to save material, not waste it.
Exactly. So that's when I was spoken with Quickgrind about their sort of options for doing so, because we realised quite quickly that wasn't a sustainable way to do so. And in doing so, they suggested we used their Spectre tooling, sort of high feed tooling. We used a sort of small depth of cut, about maybe 0.25, 0.3 depth of cut. And those tools were lasting without any issue getting through this hard skin.
And let's have a look, shall we have a look at one of those tools and see how they're lasting so well?
Yeah, so this is the Spectre tooling from Quickgrind that we used for our machining passes.
And it looks like quite, I don't know, a weird kind of three-fluted thing. I mean, do you have, what kind of depths of cut do you take this
So
tool?
this was about 0.25 to 0.3 depth of cut, slightly varying because your top surface is varying, and it had zero issues doing that. We're not trying to take off a lot of material here. It's all about minimising that waste. So taking a small cut off the top with this, enable this to last for the whole job really.
So you've gone from 15 tools down to the whole job being done with one tool?
The whole thing done in one tool. So it was a real big sort of time saver, and because we're then not in the situation of changing tools as often. You can just keep going with making the part. So
yeah, and you're saving carbide as well. So
exactly,
rather than wasting you're using additive, you're saving material in Inconel, you're saving carbide, and obviously the cost of both is going up day in, day out. Okay, and let's have a quick look at the next tool used for finishing the sides, right?
So for finishing, we use this Mirage 4-flute cutter from Quickgrind to do a sort of full flute pass to just give a nice finish.
And that's a beautiful finish you've got here that's completely different to the horrible surface finish from the additive.
It's one of the things, you might sometimes look at a deposited part and think, oh, it's a bit, but as soon as you cut away that skin, you're into some solid material that is of really high quality, as we saw on the ring. And the Mirage cutter had no issues cutting the 625 material, and it finished it to a very nice standard, I think.
It's amazing that you start from a base plate where I guess you'll deposit material from absolutely nothing to a beautiful finished part like that on the exact same machine. You just leave it running.
Exactly. You do it all in cycle. That's one of the benefits to the hybrid system that we are using here. You can deposit, machine all in one platform. There's no relocating of parts, there's no transfers of datums. It's all just done in the one cycle. You can deposit, machine, whatever you require it to do.
And trying to save carbide again, what about regrinding?
So we keep all the carbide that we've used here, and that gets sent back to Quickgrind for them to regrind, repurpose and be able to reuse it, because, well, for the wear ring here, it was only a little bit of a wear on the tool was enough for us to call it off. In some instances you might get away with that, but so the tool was still very much sound when we were done with it, and that now goes back to Quickgrind and it's back in use.